Good morning. Today's topic is seafloor spreading. Your objective is I can explain the process of seafloor spreading. Harry Hess's discovery of seafloor spreading provided the how piece that was missing for Wagner's theory of continental drift. Remember how those fixists wouldn't believe and support Wagner's theory because he couldn't prove to them how the continents had actually drifted apart? Well, now, thanks to Harry Hess's discovery, there was a mechanism behind why the plates moved. Harry Hess called his new theory the theory of plate tectonics, which state that the Earth's plates are in slow, constant motion, driven by convection currents in the mantle. Your first note today that you want to put on the left side of your Cornell notes is we're going to review what a mid-ocean ridge is from the video this morning. A mid-ocean ridge forms at a plate boundary when plates pull apart from each other. At these boundaries, as the plates are moving away, magma from deep in the mantle rises up to fill in the gap that's created. This magma is moving because of those convection currents deep in the mantle that are constantly churning. So the magma rises up from within the mantle and it spreads out to form new crust on the ocean floor. So this idea that as the plates pull apart and the magma rises up, we call this seafloor spreading because new seafloor is actually being created by that cooling magma. Your next note, you want to put your topic is seafloor spreading. The definition is that it adds more crust to the ocean floor. You want to note that the youngest rock or the youngest crust is going to be found at the ridge, right at the opening. Older rock and crust, because crust is made of rocks, is found further away as it spreads out. So take a look at this practice problem. This diagram shows the two plates. You've got an oceanic plate, two oceanic plates. That just means it's a plate of the crust that has ocean on top. And you see that they're pulling away from each other, allowing magma to rise up the middle. Which area that's marked with numbers 1 through 4 is most likely the oldest crust? Think about as that magma rises, it's going to go up over the top of the ridge and spread out. So over time, where's the oldest crust going to be found? At number 1, 2, 3, or 4. As the magma rises up and out of the ridge, it spreads out along the ocean floor, which adds that new crust, meaning the oldest crust is going to be the farthest away from the opening, because the brand new magma that comes up and cools right away, right next to the opening, is the youngest. Here you can see the boundaries of the tectonic plates that make up our crust. The red lines show the boundary. It's at these lines where the plates are going to interact. Where you see the mid-Atlantic ridge, that is an interaction where the two plates are pulling apart, causing seafloor spreading. Well, if the seafloor is spreading, wouldn't that mean that the Earth is going to get bigger and bigger? The truth of the matter is it's not going to grow forever, causing the Earth to actually get larger. This is because of something called subduction. Sub means under. Subduction occurs when the crust is actually recycled back into the mantle when the plate collides with another plate and is pushed under it. So I'm going to show you an example of this. Here we have the plate that was spreading away from another plate in the middle of the ocean, but it's going to again hit another continental plate, and watch what happens. It gets pushed underneath the other plate. So that crust, even though it was newly created back at the mid-ocean ridge, is now eventually, over time, being pushed down, and it takes millions of years for this to happen, pushed back down into the mantle where it becomes magma again as it melts. So that crust is recycled. So it's not actually spreading and growing forever, because eventually it's going to be pulled back into the mantle.